With the advancement of AI and the increasing power of each new model being released, the way we produce code has been completely transformed. There are now many tools specialized for coding, like Claude Code, Cursor, Anti-Gravity, and others, each with its own unique capabilities. But good models alone don't determine the quality of the code you produce. How you use the tool and manage context matters just as much. All of these tools have some inherent mechanism for context engineering, but Cursor just made a major push for a new approach, building it natively into the app itself. As I went through their article, I realized these principles are genuinely strong. We have a lot to talk about today because these ideas can be applied broadly to any platform you use to build applications. Context management has always been critical when working with AI agents because good context management determines the output quality. We have previously talked in our videos about how important context management is and talked about workflows for it. Cursor implemented context management features directly into their product and released an article about it. These principles are based on their observation that to get good results from models, it's better to provide as few details as possible in the context window. The less information the model receives at once, the less data it has to process at once, meaning lesser confusion and more focus on the task it needs to do at the moment, because only relevant information is included. This approach is what they call dynamic context discovery. The idea is structured note-taking. That is, the information not needed right now should not be in the context window. Excluding potentially confusing or contradictory details improves the quality of the agent's responses significantly. Cursor's current release adds 5 dynamic context management methods, rolling out to users soon. Even though Cursor is implementing this as a product update, these principles are widely transferable to all AI agents. The first update Cursor mentioned is that long tool responses should go into files. MCPs often return large responses that stay in the context window. Not all of the information from the responses is always needed. Cursor mentioned that the common approach of the most coding tools is to truncate long MCP responses, which leads to data loss or important information that might be necessary for the context being removed. Claude's Chrome extension is a very tool-heavy extension, and just a few prompts can fill up the context because of loading a huge chunk into the context window. So I added an instruction in the claude.md file that any MCP tool response greater than 50 lines must be saved to an MCP folder within the .context folder by running an echo command in the terminal. When I ran the Chrome extension to analyze the UI of a landing page, whenever Claude came across a tool like read page that significantly bloats the context window, it saved the MCP response into a file for further reading, using which it analyzed the whole page and gave me a report. This workaround improved the accuracy of the tool response analysis by letting Claude analyze the responses from files as many times as needed and eliminated the need for repetitive tool calls. When data from previous MCP calls is needed, Claude can read it directly from the context folder instead of making tool calls, saving significant time. Before we move on to the next change, let's hear it from our sponsor, Zenrose. If you're building AI products, automations, or data-driven systems, you already know one thing: everything starts with reliable web data. But getting clean, structured data at scale is harder than it sounds. That's where Zenrose fits perfectly into the stack. Zenrose handles data extraction from complex websites while automatically managing anti-bot bypass, so you can focus on what actually matters using the data. Instead of dealing with messy outputs, Zenrose delivers structured results like JSON or Markdown ready to plug directly into your pipelines. It's integration ready and business focused, which makes it ideal for AI startups, data teams, and automation builders who don't want to babysit infrastructure. Whether you're enriching leads, powering AI agents, or automating research, Zenrose just works. If your work depends on web data, Zenrose belongs in your stack. Click the link in the pinned comment and start building today. We know that the summarization step when the context window is filled is messy and leads to losing a lot of information. Most tools, including Cursor and Claude Code, trigger a summarization step and start the session with a fresh context window with the summary as a starting point. When you hit compact again and again, the summary starts to forget details that might be important to you, but that the model's summary may miss. There is only so much control you have over auto-compaction, and repeated compression leads to the loss of crucial information if you have to do it repeatedly. Cursor's solution is to save all previous chat history as a file for the agent to reference later. When we provide a very specific prompt and the model cannot find the information in the summary, the previous transcript serves as its knowledge base. The model uses that transcript to generate the solution, allowing it to recover anything that was lost from the summary. Until Cursor's implementation rolls out and becomes available for everyone, I tried implementing this feature with Claude Code. I added the instruction inside the claude.md file to update the chat history after each turn, documenting all the key decisions and steps taken. It used a history folder inside the .context folder with each file's name reflecting the session. So whenever I ask it to perform any task, at the end of its task execution session, it documents the chat history into the corresponding history file, adding everything to that file. This way, the .context folder contains detailed records of all sessions and everything that was done. Agents were given skills to help manage the context problem MCPs were causing. The whole purpose of skills is to make agents provide better ability to use its own capabilities by guiding through scripts and instruction files, reducing context bloat by progressive disclosure. Anthropic was the first to come up with the idea, which is basically giving the agents a set of instructions, scripts, and resources that the agent can discover and use to perform better at specific tasks. Anthropic basically open sourced these agent skills, setting a standard that others could implement. Following this, Codex, Gemini, and others started implementing agent skills, after which it was finally Cursor's turn to do the same. Cursor's skills are basically the same executables and scripts bundled together into a single skill that the agent can use for its respective tasks. Only the skill's name and description are in the static context. Once they are inside the static context, the agents can pull their skills on their own using grep and Cursor's semantic search. This is what makes it different, because Cursor's semantic search uses its own embedding model and indexing pipelines in the background instead of plain pattern matching like regex-based searches in grep commands. Claude skills only expose the name and description in the context, no matter how many files the script uses, preventing context bloat. In my project, I had configured 5 skills, each consuming very few tokens, only about 0.2% of the total, leaving more room for working. What's different is that Claude skills can also be accessed via /commands, letting you manually trigger them whenever needed, addressing people's complaints about skills not being loaded on demand properly. MCPs contain a lot of tools all exposed in the context window, bloating the context window unnecessarily. Cursor took it upon themselves and emphasized that it is the responsibility of the coding agents, not the MCP servers, to fix the context bloat. The solution for this was dynamic context discovery by syncing tool descriptions in a folder. Cursor's idea is to have all of the MCPs with their names in separate folders named after each connected MCP, and within each folder, all the tools must be listed. With this, the agent only receives the names of tools, and whenever it needs any tool, it looks it up through the folders. In the testing they did, they discovered that dynamic discovery of MCP tools reduced usage by 46.9%, which makes a huge difference if you are working on a long-running system. This implementation also helps in cases where MCP servers accidentally get disconnected or require reauthentication. Normally, the system would just forget about those tools, but now the agent can actually notify the user that reauthentication is required. Claude also has an advanced search tool that is specifically designed to address this problem, using a certain set of flags to let Claude know whether to load it or not. It implements Cursor's exact idea of dynamic context discovery, but this is limited to the developer platform and only for those building with APIs. We cannot modify how MCPs are used in Claude Code because they are built into it by Anthropic. Just as I was looking for ways to implement this in Claude Code, I came across a hidden flag. Without setting this flag, all the MCP tools I had connected were exposed in the context of Claude Code. When I set the Enable Experimental MCP CLI flag, all the tools were removed from the context window, freeing up space that was previously occupied by the MCP tools. But that does not mean the MCPs get disconnected when this CLI is enabled. The only difference is that they are not exposed upfront in the context window. Instead of putting all the schemas into the context, Claude now uses a middle bash layer called MCP CLI, which handles all MCP related tasks. Claude uses this middle layer to search, get information, and invoke the tools. Whenever you ask Claude to perform any task that requires an MCP tool call, instead of using the usual method, it uses the MCPs via MCP CLI and performs the task it is required to do. By using this tool, Claude executes all the tasks as usual, just through this middle layer. Reporting terminal errors is hard in Cursor because of its limited access. If the terminal showed any error, you needed to add it to the chat and then have it fixed. Cursor's solution for this is also moving the terminal sessions to files. So whenever you ask it any questions, it references those history files and uses grep to extract the relevant output. Since server logs are usually long-running and contain lots of noise for the agent, using the grep task is more efficient because it lets the agent pattern match. They got this idea from CLI-based coding agents, which run the commands, but then the output is injected into the context exactly the way Claude Code and others do by default. Even though Claude intelligently handles this on its own, we can manage it even further by using instructions in Claude.md to instruct it to add all terminal logs into a file in the terminal folder inside the .context folder. Basically, if Claude runs any npm command, it runs a special command that logs both the output stream and the input stream into the document files. Here, 2 represents the standard error stream and 1 represents the standard output stream. It writes these logs to the terminal folder, marking them with a timestamp. Then, whenever it needs to search through them, it simply uses a grep command with a specified pattern and loads the last 20 lines to extract only what matters. So whenever I tested my development server, it used these commands and kept writing the terminal runs to files in accordance with the claude.md file. After running the server, it referred to the log files and figured out what was causing the issue and fixed the problem for me. Now, even though this add-on to Claude Code might seem insignificant because it doesn't appear to have much impact on immediate work, it can be very useful when you want to refer back to your app's functioning. Just like when I needed to identify which service was causing my app to crash, I simply told Claude to refer to the test logs instead of running the tests again, saving me from rerunning a 2-minute test suite just to reproduce an error I had already seen. That brings us to the end of this video. If you'd like to support the channel and help us keep making videos like this, you can do so by using the super thanks button below. As always, thank you for watching, and I'll see you in the next one.